Okay, now let's talk about divisibility tricks. I'm not going to teach you all of them, but there's a few little tricks to knowing when a number can be divided by another number. It's going to be very, very useful. You probably know some of these already. The first one is if a number ends in 0, 2, 4, 6, or 8, it is called an even number and it has a factor of 2 in it. It can be evenly divided by 2. One of the prime numbers in it is a 2. These are even numbers. Another one is if the number ends in 0 or 5. There's a 5 in it. It's divisible by 5. The last one, a little bit tricky. If you take all the digits of the number and add them up, if the end result, which will invariably be a smaller number, if that number is evenly divisible by 3, then the whole thing is divisible by 3. Let's do an example. Let's say we have the number 1,656. 1,656. What can this be divided by? Now here, okay, I want you to be able to do things like 20 or 12 in your head. 20 is what? 2 times 10, the 2 is prime, the 10 isn't, the 10 is 2 times 5, and we're done. 12 is what? 3 times 4, 3 is prime, 4 isn't, 2 times 2. I want you to be able to do things like that in your head. 1,656, I'm not expecting you to be able to do that in your head. I will need to do it out. Let's see. I'm rather partial to these. It's sort of like a wedding cake. The factor cakes. This number can be divided by 2. It ends in a 6. It's an even number. So if we divide it by 2, 2 goes into 16 8 times. 2 goes into 5 twice with a remainder of 1. Bring the 1 over. 2 goes into 16 8 times. We have 2 goes into 2 times 828 is 1,656. 828 also ends in an 8. So it can be, it's also an even number. It can be divisible by 2. 2 goes into 8 4 times, goes into 2 once, goes into 8 4 times. 414, still an even number. We can divide that by 2. 2 goes into 4 twice, 2 goes into 1. It doesn't carry the 1. 2 goes into 14 7 times. Aha! Now, first of all, by pulling out the numbers that we know, the easy ones, the 2's, we're now dealing with a much smaller number. But still, 207. What divides 207? Well, 2 plus 0 plus 7 is 9, and 9 is evenly divisible by 3. That means that this number can be divided by 3 with no remainder. 3 doesn't go into 2, it goes into 26 times. 3 times 6 is 18. If you take an 18 away from 20, there's going to be a 2 left over. 3 goes into 27 9 times. 6 plus 9 is 15. That can be divided by 3. This whole number can be divided by 3. 3 goes into 6 twice, and 9 3 times. 23. 2 plus 3 is 5. 5 cannot be evenly divided by 3. Therefore, there is no 3 in 23. 23 is not divisible by 2 because it's not even, not divisible by 3, not divisible by 5 because it doesn't end in a 0 or a 5. What else do we have to worry about? Well, actually, if 23 was 2 things multiplied together, I'm not going to get into this. It's a prime number. And this is the sort of thing that I'm going to throw at you. I'm going to give you a large number that's got 2's and 3's, maybe some 5's in it, and then maybe one horrible prime number. I mean, probably the nastiest thing I could give you, and probably won't even give you this, is something like 7 times 13. 7 times 13, 21, 7, 91. 91 looks like it might be a prime number. It's divisible by 7 and by 13. That's tricky. There's no good tricks for 7s. There's no good tricks for 13s. But what have we figured out? We figured out 1,656 is 3 2's, 2 3's, and a 23. Well, okay, 2 times 2 times 2 times 3 times 3 times 23. That is the prime factorization. The cute way of doing that for people who don't want to have to keep multiplying is 3 2's is 2 cubed, the exponent. 3 times 3 is 3 squared, and a 23. So this is the fingerprint of 1,656. It's 3 2s, 2 3s, and a 23.